Good afternoon from Los Angeles, California. My name is Marin Steiner, and this is week number 7 of General Chemistry 2. And today we're going to do Advanced Concept Presentation 7, which is magnetic fluid. We know that magnets contain very interesting properties, and in this experiment we're going to attempt to use a magnet to manipulate a fluid and try to help explain why magnetic fluid occurs. Ferrofluid is a liquid that is attracted to the poles of a magnet. A process for making a ferrofluid was invented in 1963 by NASA's Steve Papel to create a liquid-fueled rocket fuel that could be drawn towards a fuel pump in a weightless environment by applying a magnetic field. Ferrofields are composed of very tiny nanoscale particles, diameter usually 10 nanometers or less, of magnetic hematite or some other type of compound containing iron as a liquid. And this is small enough for thermal agitation to disperse them evenly within a carrier field, and for some of them to contribute to the overall magnetic response of the fluid. This is similar to the way that the ions in an aqueous paramagnetic salt solution, such as an aqueous solution of copper, sulfate, or magnesium chloride, make the solution pragmatic. The composition of a typical ferrofluid is about 5% magnetic solids, 10% surfactant, and 85% carrier by volume. Common applications for this include electronic devices. Ferrofluids are used to form liquid seals around the spinning drive shafts and hard disks. The rotating shaft is surrounded by magnets, and then a small amount of ferrofluid placed in the gap between the magnet and the shaft will be held in place by its attraction to the magnet. Also, mechanical engineering. Ferrofluids have friction-reducing capabilities if applied to the surface of a strong enough magnet, such as one made of, I think it's pronounced neodymium. It can cause the magnet to glide across smooth surfaces with minimal resistance, which is what we're going to show today in today's experiments. Ferrofluids have been used in loudspeakers to remove heat from the voice coil and to passively damp the movement of the cone. They reside in what would normally be the air gap around the voice coil, held in place by the speaker's magnet. So in the future, there's a lot of research going into this, and this might be used for spacecraft propulsion, analytical instrumentation. Medical applications are being looked at, including magnetic drug targeting, which would be really cool, heat transfer applications, developing different types of optic systems, and even energy harvesting, which is a big topic here in California. So this is interesting to see how this unfolds. So for today, our recipe calls for the following items. So we have a laser jet toner, which we're going to attempt to extract from here. A magnet, which we have right here. I have two different kinds just in case one of them doesn't work. We have vegetable oil, which is we have right here. Our measuring spoon, which we have right here. And then we have a cup to put all this in, and we're going to try and do a transfer of this cup as well. So the first step of this project, we're going to pour some laser jet toner into our cup. So we will try that right now. So we've got our toner here in the cup. And next we're going to pour our vegetable oil. So we want 2 tablespoons of vegetable oil. I'm not quite sure if we have enough toner, but we will give this a shot. So 1, 2. So next we're going to stir this mixture together until we have a nice consistency. So we'll take our spoon here. So based on the videos that I watched, if it doesn't have a nice thin consistency, then it might not work properly, this experiment. And since I seem to have a history of some of these experiments not working, we're going to mix it really good. It's killing my straw here. So now that we have our mixture, we're going to pour it into another glass to make handling it easier, although I think this will work in this glass here. So we have a mixture, we're going to pour it into a smaller glass, which we said we're not going to do. So let's test it out. So the goal is to have our magnet, place it into our container, and see if the liquid magnetizes. So here is our magnet right here. So let's see if this magnetizes. It does not magnetize. So I'm told if there's not enough toner, then we risk it not magnetizing. So our second step, we were supposed to pour a little bit under the magnet and try and get the same effect. But since this is not magnetizing, obviously, we have an experiment fail. But it was a good experiment. We tried our best, and now we know we need more toner to do it in the future. So we will see you soon for week number 8. Bye for now.